In this video, we're going to look at topic 73, example 3, where we multiply complex numbers. How can you write each product in the form a plus bi? So what we want to do is we want to treat these, for the most part, as if the I was just a variable. Okay, don't overthink this. Just pretend that this is negative 2.5x times 8 minus 9x, and apply the same properties that you would apply in that case. And then there's just one thing we have to look out for, and I'll point it out when we get there. So we're going to take this negative 2.5i and distribute it in. So we have negative 2.5 times 8, which is negative 20. The I comes along. And then we have negative 2.5 times negative 9. So we get a positive 22.5. And then I times I would be I squared. So there's nothing we can do with the negative 20i. That's going to remain the same. But if you remember from the previous video, I squared is equal to negative 1. So anytime we have an I squared, we need to replace that with the negative 1. So this here needs to become negative 1, which will then change our sign for that 22.5, right? So we have 22.5 times a negative 1. So this would be negative 20i minus 22.5. Let's fix that too. Unlike terms, we cannot combine negative 20i and negative 22.5. However, they do want us to write this in a plus bi, so our complex number form. So we want to rewrite this as negative 22.5, negative 22.5, there we go, minus 20i. And that will be our solution. So the new piece is that I squared. Anytime we have I squared, we want to change that to a negative 1. Part B, you're looking to do the same thing, right? We're looking to distribute, right? Remember the FOIL method. So first, outer, inner, and last. We'll just multiply everything out. 3 times 3 would be 9. 3 times 2i is a positive 6i. My inner ones, negative 2i times 3 is negative 6i. And then negative 2i times a positive 2i would be negative 4i squared. From here, we want to look to combine any like terms, and we also want to remember that I squared is negative 1. So the 9 stays the same. Positive 6i minus 6i, those two will cancel out. And then we're going to subtract 4 times negative 1. All right, negative 4 times negative 1 is a positive 4, and 9 plus 4 would be 13. All right, in this case, sorry about that, just making sure this is all worked out right. In this case, we don't have a complex part, right? There is no bi term. So the answer is just 13. What you're going to see is these two groups here, this 3 minus 2i and 3 plus 2i, these are called complex conjugates. We'll get into a lot more detail in the next video, video 4, and we'll talk about what complex conjugates are and when they're useful and how we can use them to our advantage. But effectively what happens with complex conjugates is that your complex parts are going to drop out. All right, it's a way to eliminate a complex number from an expression. So number part B, since we have 3 minus 2i, 3 plus 2i, the same terms, just with that different sign in between, they're called complex conjugates. And again, it's a way for us to eliminate the complex number, okay, or the complex part. But effectively, or with these, you're doing these just like you would do a normal multiplication problem. The only thing you have to look out for is that I squared, and set I squared equal to negative 1.